Hey guys, so this is going to be part 2 of day 4. This is the back page. This is page 4. And we just had 2 proofs here, proof 4 and proof 5, that I wanted to look at real quick for you guys. Even my people in class want to take a look at this one. And the reason is because these two are a little bit different. We're given kind of, looks like same side interior here, right? 15 plus 8 equals 180. Here's 15. Here's 8. So, okay. So they're not same side interior. Interesting, but we still know they're going to add up to 180. This could be more an issue of maybe supplementary, because 15 and 8 are not same side. They're not same side here. 15 and 8 aren't. But they look like they're going to be supplementary, so we'll think about that. Also, look at what we're trying to prove. This is the big one. If we're trying to prove that 2 lines are parallel, I want to take you guys back to the first page of this day. Remember, if we're trying to prove that 2 lines are parallel to each other, we're going to be using converse. It's all about converse to prove that angles are to prove that lines are parallel. So there's definitely going to be some converse going on here. We know that just straight up based off what we're trying to prove. So let's get to it, guys. Let's get to it. So we're given that these 2 angles add up to 180. Okay. We'll come back to that. In the meantime, we know 9 and 15, speaking of 15, 9 and 15 are going to be vertical angles. That's a good old-fashioned statement. That's based off the definition of vertical angles. Now, because of that, that then means that 9 is going to equal 15. Well, remember what we talked about today. Definitions a lot of times lead to theorems. The definition has the words, the theorem has a statement. Vertical angle theorem. Now, check it out. We knew 15 plus 8 was 180. Well, 15 plus 8 is 180, and we know 9 equals 15. It looks like we are replacing angle 9 we're replacing angle 15 in with angle 9. Check it out. 15 plus 8 is 180. We are substituting in angle 9 to take that spot. Oh, we're substituting. A substitution. And then, oh, shoot. Look at these next 2 steps here, guys. These add up to 180. The math leads into, that must mean they're supplementary. If we have math, then words, and the steps are connected. Remember what we talked about? I know me and Jack in first period talked about this. Math leading to words. That's going to be a converse definition of, so I don't know why I put 2 F's, definition of sup. Yep, the math leads into them being supplementary. That's a converse of the definition. We got to flip it. Now, we're back to, looks like 9 and 8 are same side interior. This is just a word statement. It's not connected to the supplementary idea before at all. It's just 9 and 8 are same side interior. Well, that's just based off the good old-fashioned definition of same side interior angles. Forgot the interior part. Same definition of same side interior angles. And then, because of that, because they're same side interior, that leads to us proving parallel. And if we're proving parallel lines, that is always going to be, always the converse, always, of the same side interior angle theorem. Converse of the theorem will be what lets us prove we have parallel lines. Always, always, always. And we knew that from the very beginning. So guys, I'm going to give you a chance. Let me leave that there for a second. And then I want you to try number 5 for me. And again, look at that. Parallel. That means we're trying to prove parallel lines. That means we're going to have converse to finish up again. So be on the lookout, guys. Converse is going to show its ugly head again. And it may show up in another spot too. Okay, so we know These two angles are adding up to 180. That's what they tell us. And because of that, because they're adding up to 180, think back to the previous problem. If they're adding up to 180, doesn't that mean they're going to be supplementary? Yeah, if they're adding up to 180, they're going to be sup. But wait, if it's math that leads to words, oh shoot, we got it again. We got a converse definition of sup shows up again. What else are 4 and 5 going to be? So we know they're supplementary. If that's a parallel line and that's a parallel line, aren't these on the same side of our transversal? Here's our transversal cutting through. Same side on the interior part of these lines. Aren't these going to be same side interior angles? Heck yeah. Same side of the transversal inside. And again, we can make that statement based off the definition of same side interior angles. And just like before, if we're dealing with same side interior angles, that leads to us having parallel lines. And if we're trying to prove that, it will always, always, always be the converse. In this case, we're dealing with same side interior angle theorem. Yep, that's the pattern, guys. If you're trying to prove parallel lines here, dealing with these definitions and theorems, you know you're going to have the converse of these theorems. So thank you guys very much. Don't forget about our quiz tomorrow.